Hello and welcome to another video presentation courtesy of the University of North Texas Physics Department with the assistance of the Physics Demo Room. Today we'll be talking about is 2D motion and using a projectile launcher to help illustrate how our motion is going to affect a projectile. So what we're going to be having here today is this is just a little cart with a projectile launcher and we have a little yellow ball. And so what we're going to do is we're going to have this cart and we're going to move it along and launch a projectile. Now with this apparatus, if I have this cart moving at a constant velocity in the x direction, when I launch this projectile, I should be able to catch it in the basket as well that is on top of here. Now you might be saying, well, how does this work? Why is this allowed to do this? And that's because this is all dealing with two-dimensional motion. So if we think about it as the cart is moving, once it gets launched by the projectile, it only has a velocity in the y direction from the launcher, but the launcher was moving as well. So for example, if I was to not have this cart moving and just activate the launcher, if the ball goes straight up, straight down. Reason for that is it's going to go straight up and straight down because we have the acceleration due to gravity is always pulling against it. So that's why the ball gets launched up, has a maximum height, and comes back down. But now if we also have this thing moving in the x direction, whatever this launcher was doing is still going to hold true, but now it's also launching it with respect to the speed of the cart. So if we were to look at the components of the velocity, because remember velocity is a vector, we can see here that the initial velocity upwards is from their projectile launcher, but it also has a component in the x direction. So that means our total velocity component will be at some angle that is both in the x and y direction as the magnitude of our velocity vector. So if we were to take snapshots at different time intervals of this parabolic path that this projectile is going to be going through, we can see that initially the ball, as we see on the board, the ball is in our little container or our little projectile launcher. It gets launched, and then at some point later, at the top, when it's at its maximum height, the carriage should be underneath it exactly the same as you see on this board. And then at the final point, we have our final velocity should equal the initial velocity of ascent, but the ball should reach our container. Now remember though, at the top of this arc, the velocity has to be zero. It can't be it can't be a positive number or a negative number. Because we have to think about it. In order for the velocity to go from a positive number to a negative number, it has to go through zero. So that reminds you that at the top of the arc, the velocity is zero, but the acceleration is always going to be constant throughout this whole path that it's traveling, which is negative 9.8 meters per second, because we are assuming positive is upwards. So now, if we were to look at this little demonstration, I have the cart primed, and now I'm just going to move it. As you can see, it did catch it. It just wanted to bounce out. So let me try it one more time and see if I can get it to stay in there. Two times, really close. But as you can see, it's not that it did hit the cart frontwards or backwards. It hit it and then just bounced out. So that just means that we're just a little bit off when it comes to hitting the padding. So now we have another idea. Is that, well, if this is true, I should be able to do this again and be able to make a tunnel. You kind of see this done a lot when it comes to movies, to where all of a sudden someone will be on a boat, on a river, they'll jump up, they'll keep going across, and then they'll land on there, or they'll jump out and they'll be caught on the other side of the bridge. That's all because it's a constant velocity and the air resistance is very negligible for them. So now let me try this one more time. Hey, I got it there on the last one. But as you can see, it jumped up, was able to clear this little tunnel that we have here, and land on the other side. So that is all for this video presentation today. Thank you for watching and have a wonderful day.